Hiya, in this video we're going to look at National 5 trig identities questions. Now, these aren't always taught. Some teachers take the educated decision to not do these at all, because at the end of the day they're only worth 2 marks in an exam. But if you want to go on and do higher, then these are important, and you do need to remember them. So it's worth showing you them just in case, because they're generally not too bad if you can remember 2 extra wee formula. So you need to remember these must be learnt, okay? They are assumed that you know them off by heart at higher, and at higher we show you other ones as well to use. So basically what we do is we substitute these into expressions to complete normally what's called a proof question. So sometimes they'll say simplify something, and other times they'll say prove that this is equal to this. They're the nicer ones because you can see what you're trying to get. So from these 2 formulas, whenever you see the tan one, I'm going to start with that first. Whenever you see an equation with a show that or a simplify and it's got a tan x in it, we can replace tan x with the fraction sine over cos, okay? If you see ones with a sine squared or a cos squared, it's going to be using this other formula on the left. Now, by remembering this formula, it means we can also get an expression for sine squared x. So sine squared x would be moving the cos over, and that would give you 1 minus cos squared x. And similarly, we can do the same and get an expression for cos squared x. That would be moving the sine over, and that would be 1 minus sine squared x. Because sometimes you will see either the left-hand side or the right-hand side of these wee equations I've just made, and you've got to replace them. So it all comes from remembering the 2 that I had at the start of the screen. You don't need to necessarily remember these 2 off by heart, because you can manipulate the sine squared plus cos squared one. So let's have a look at some of these. I've got quite a few examples, and then there's some questions at the end you can try from previous exams. So simplify this. Now straight off you can see it's a bracket, can't you? Squared. So the first thing I'm going to do is write out sin x plus cos x, sin x plus cos x. If you're not comfortable using the words, you could always write it as s plus c, and then put the words back in at the end if you wanted. Right, so using the method of multiplying out, I'm going to use the claw or FOIL. We multiply the first 2 things. That gives you sin x times sin x, which is sin x squared, but we don't write it as sin x squared. We write it as sin squared x. The reason being is, see if you write it like this, you won't get the marks in the exam, because that looks as if the squared is with the x, okay? So watch out, the squared goes in next to the word sin. So that's why I actually start to just say sin squared x. Then we're going to do sin times cos. So that just gives us sin x cos x. Then the middle 2 will give us cos x sin x, which is just the same. So I'm just going to put the sin one first because I've already got that. So I've got plus sin x cos x. And then I'm going to have cos times cos, which is cos squared x. Remember, the squared goes with the word, not the x. And then if you tidy that up, 2 things in the middle are the exact same. So you've got 2 of them. So you've got sin squared plus 2 sin x cos x plus cos squared x. Now, you might think you're done, but remember, on the slide just before, we had one of the formulas, and it said that sin squared plus cos squared equals 1. So those 2 things are equal to 1. So we really have 1 plus 2 sin x cos x. Obviously it would be okay to put the 1 at the other side as well and write 2 sin x cos x plus 1. So that's that first one. Remember also, if some of you might not multiply out brackets that way, some of you might do it using the table method. So that would just be the same. You would just put sin x cos x, sin x cos x, like that. Sin times sin would give you sin squared. That would give you sin cos. That would give you sin cos. And the end ones would give you cos squared x. And then when you tidy them up and write it out, you'll just get back to the same as we had above. Okay, so one of them was done, I think, in maybe 2 years ago in the exam, and it wasn't particularly well done. And the main reason is because people were writing sin x squared, and they weren't getting the marks for that at all, because that's wrong. Okay, my next one, we have to express this in its simplest form. Now remember, I said whenever you see tan x, you can replace that. Tan x is sin x over cos x. So what we've got is sin x times cos x. I'm just going to spread this out. Times, and I'm going to replace that with sin x over cos x. Now, that cos is multiplying, that cos is dividing, so they're going to cancel each other out, leaving you with sin times sin, which is sin squared x. So whenever you see tan, put in that fraction and see what you can do. Here's another one. We've got tan squared this time. So if tan is sin over cos, right, then tan squared is just the exact same. And let me prove why that is. So if tan equals sin over cos, then tan squared is just going to be that fraction times itself. Yeah? Which would give you sin squared over cos squared. So the squared bit just means you can just square both of the bits on the fraction. So I'm going to replace that tan squared with sin squared x over cos squared x. And they're stuck together, so they're timesing. So times and cos squared x. So you've got a times cos squared, a divide by cos squared. They're going to cancel out, simply leaving you with sin squared x. And that's that one done. Also though, sin squared x could be replaced with 1 minus cos squared x coming from my first slide. And if that had been approved, that question, it might have given you to prove that one, but I really don't think you wouldn't go that far. I would just leave it as sin squared x if it wanted, because that's much more simplified than 1 minus cos squared. Okay, my next one, show that tan x cos x equals sin x. So a show, that means you just leave this side completely alone, right? This is what you're aiming to get. You don't start moving things over and putting it equal to 0. It's not an equation. It's telling you to show that this is your answer. So that's what you're aiming for. So remember I said whenever you see tan, you replace that with sin over cos. So sin x over cos x. And that's times by cos x. This is very like the last one I had with the squareds. So the cos's are going to cancel out, leaving you with sin x. And that is exactly as you were required to get. So the answer is sin x as required. So what I like about these ones is if it's a show that, then you can, if you get to that answer, it's like, oh, there's 2 marks I've got. It's almost like telling you to try and make sure you can get that answer. My next one, there are 2 ways to do this one. The most obvious way is, remember I said, whenever you see tan x, you write sin over cos. So we're going to do that method first. So tan x equals sin x over cos x. Now, I can now replace cos x and sin x with those fractions, but I don't want to, because then I'm going to have fractions over fractions. But another way of writing sin divided by cos is writing it left to right as that. And people forget you can do that with fractions. So writing it like that, I'm now going to replace sin and cos with those fractions. So I've got 5 over 13 divided by 12 over 13. Now remember, you are told when it's dividing fractions, you keep it, keep the first one, change the sign, flip the second one. Keep it, change it, flip it. And then you've got a 13 and a 13 that will cancel out, leaving you with 5 over 12. Now there is another way, but it requires you to remember your SOHCAHTOA knowledge. I'm going to draw a wee right angle triangle, and this is angle x. Now remember, sine is opposite over hypotenuse. So here is your opposite is 5, your hypotenuse is 13. Cos was adjacent over hypotenuse. So adjacent was this one that's blank, so that would be 12 over 13. Now tan is opposite over adjacent. There's your opposite, there's your adjacent, so that would be 5 over 12. So 2 methods for that one, okay? And that's actually a wee insight into something you'll have to do at higher. Okay, and generally at higher we do it from the triangles. And then for my last example, this one is a bit slightly different because this one requires a little bit of common factor work. So you'll notice both things have got sign in common. Remember, we're leaving this bit at the right hand side alone. That's what we're aiming to get, okay? So that's our aim for our answer. So we have a common factor here of sin x. So I'm going to say that that is sin x bracket. The cubed becomes sin squared plus cos squared x, because we're removing that there. Now the bit in the middle, sine squared plus cos squared, that was one of the formulas we wrote at the beginning. That is just equal to 1. So that just leaves us with sine x. So now comes the part where you can pause and try my questions. Now a wee tip for question 5, you're going to replace that top line with the bit from the formula. So that 1 minus cos squared, you should see, is that in the formula. So that's what you're going to replace, okay? I haven't particularly done any like that, I've just noticed. So see how you go. So there are 3 slides of questions and they're all show that ones. So you don't need to then look on for the answers. So here's the first 5. There's the next 4. Now I haven't put an answer for question 6 in, but I'm going to tell you just now that question 6 should give you 4 over 3 when you get to that one. So that's very like one in my examples. So it should give you 4 over 3. And then there is the last 5, okay? So remember again, this 1 minus sine squared, you're going to replace from the formula up there. Okay, good luck. Thanks very much.